So a quick solution to this is to draw all the forces on A, B, and C, right? Let's just look at it as a, let's go through the solution very quickly. Most of them is pretty simple. It's really just to ensure you're not inventing any force that isn't there, all right? So let's start with a free body diagram for A. Okay, we'll do it the most cleanest way with just representing it with a dot and nothing else, right? So we really can distinguish it from the free body diagram, the physical diagram from a free body diagram. Okay, so what's touching it? The string over here. So you have a tension. That's all, okay? And nothing else is touching it, right? So we're ignoring air resistance and everything. So what else? There's gravity. So that's it. That's the free body diagram for A. If you're really uncomfortable, you can draw a box, but that is all you need. And now let's do the free body diagram for B. Okay, again, that's representing B. What's touching it? Well, the tension, string, which gives the tension. It's pulling it up. And what else? Nothing else is touching it. There's air, I was going to say, but again, we don't worry about air resistance. And then there is what's not touching it, yet give it a force, so gravity, right? So you have G over here. Again, let's try avoiding, because are you sure the gravity on this guy is the same as the gravitational force on this guy? Not necessarily, until you're convinced that they are. Let's call them separate variables. So let's call this G prime and T prime, right? Or G dash and T dash, whatever you like to call it. And C is the only one that is slightly tricky, and which also gives me an opportunity to distinguish what's a physical diagram and a free body diagram, right? So what's touching it, right? So there's a couple of things. Well, there's this string, this string, this string touching it. There's also gravity, right? Gravity is kind of the easy one. Let's draw that first. Let's reverse that. I know I'm repeating the variable. I'll fix that in a second. Now, the other easy one is this string, right? This string is pulling it upwards. So any string has a tension, right? So it's going to pull it upwards. So we're going to draw a tension this way. So this is a tension from ceiling. Okay. And there's this string and this string. Okay. So there is also a tension. Let's make the dot a little bit larger so that I don't overlap my arrows, so that we can actually see what we're doing. So tension from the left, from the left string, and a tension from the right string. Okay. So this is the correct free body diagram for C. Notice I'm drawing everything from the center of mass like this. Even if I draw the whole pulley there, we want to draw everything here. And do not draw the, if you look at the textbook, it's often they will draw T from the left, T from the right, and T from the ceiling, and gravity here. This is only half correct. I would call this more appropriately a physical diagram, because you're physically talking about where the forces are. It has its use, and we will look at this type of diagram later on in the course. But at the moment, it's much more simpler if you treat everything from the center of mass. All right. So this wraps up our chapter 2 on forces, and we'll look at how do we combine this and analyze Newton's first law and second law, and how this affects motion in the next chapter. All right, so see you in the next lecture. Have a good day.